right, good morning, everyone. So today, talking about managing security operations. So specifically, we'll be talking about applying foundational security operations, addressing personnel safety and security, provision resources securely, apply resource protection, manage services in the cloud, perform configuration management, and making changes. All right, so it's a lot of content, but luckily we don't have to go too far in to a lot of it. All right. So for the foundational concepts, a lot of this is going to be a review. Okay, we've talked about least privilege. What's least privilege? Exactly right. Okay, so we've already talked about that, separation of duties and responsibilities. You don't want one person to have access to everything. All right, so whenever you are going through and you're deciding who gets access to what, you want to make sure that you're separating the duties where it makes sense to. So for instance, would you have the same person managing the finances also managing purchases? You probably wouldn't, okay? So another way to think about this is two-person control. So beyond having separation of duties, okay, you can also have two different people sort of control who has access to what, okay? And that's a very important concept because if you think about stuff like the Cold War, all right, you guys familiar with the nuclear devices? Is it a single key to launch a nuke? It's multiple keys, isn't it? All right, it's two-person control. Okay, so job rotation. So job rotation and mandatory vacations both have a similar, I wouldn't say purpose, but certainly similar effect, where the idea is with job rotation provides you with several advantages. Okay, so one of the advantages is cross-training. It's a good idea to have employees be able to do different things, because let's face it, does everyone come to work every day? Look around, over half the class is out today, all right? So, imagine if this were a workplace, half the workforce were out. Would that be a bad thing? Be a very bad thing. Yeah, Haley. So it depends on how the organization is configured. I think that in some cases, I think that may make some sense. But I think that in a lot of cases, what separation of duties is really referring to is it's saying one manager is responsible for one department, but not other departments. Okay? And then, you may have, like, let's say you had a system administrator. You had the manager of that department. They may have control of the systems, but they may not have control of the desktop image. They may not have control of purchasing IT equipment. So that's really what separation of duties is referring to in most cases. All right, but kind of going back to job rotation. So having people cross-trained is very beneficial. Okay, but beyond that, okay, we also receive benefits because if people are constantly job rotating, the idea is that from a security perspective, if one person is doing stuff that's not on the up and up, okay, let's say they're committing a little bit of fraud, okay? So fraud is not fun, all right? It'd be pretty bad if I didn't say that fraud was bad. All right, one of the things I'm required to do, actually one of the things that you're required to have in the curriculum is ethics, okay? That's your ethical lesson for the day. Fraud is bad, all right? Is anyone confused? Should be a pretty straightforward lesson. But if you're job rotating, fraud's a lot more likely to get noticed because it's not just one person with control of something, it's basically shared. Same thing with mandatory vacations. A lot of organizations will require you to take a 1 or a 2 week vacation at some point in the year. And that's not just for mental health, believe me, okay? I think that most companies want to minimize turnover because it's not a cheap process to go through to replace an employee. But, mandatory vacations, they're really there to sort of help detect any fraud. Because let's say a purchasing director, okay, is making some purchases for themselves, all right? And you have someone else come in and do purchasing for a couple weeks. They're going to be a little bit suspicious of those purchases, right? So that's the idea behind mandatory vacations and job rotation. Now, you can make an argument that job rotation is not really a practical thing, all right? Because let's face it, is it free to train? Paying in some way, shape, or form. All right, so that's costly. Mandatory vacations, you can make an argument that's free. Well, at least it's already paid for. Because if you're allocating vacation days, those are already paid for, right? Okay, privilege account management. It's pretty self-explanatory. If you have an administrative account, maybe it's a system administrative account, maybe it's a local administrative account, whatever the account is, you're protecting it. Okay, you're not allowing it to do, well, I wouldn't say you're not allowing it to do things. It's a privileged account. By definition, it can do things. It's more about your monitoring it, you're logging it. Okay, and then lastly, service level agreements and memorandums of understanding. Okay, so a service level agreement is going to be an agreement between an external provider, although they can be for internal departments as well. Generally speaking, though, it's going to be an agreement where you lay out the conditions of service, and you basically set a baseline for the service that you'll be receiving. And you're also going to include what happens if that baseline isn't met. Okay, so most of the time, it's going to be hard to find a vendor who will agree to anything for a penalty other than they're going to allow you to get credits for additional service for free. So it's not uncommon if you have an enterprise ISP to say that for every hour of downtime, that's 3 hours credit. Okay? That's for an enterprise contract. You're paying a lot more for that, right? What do they tell you for a consumer contract? Most of the time you don't get anything, all right? I'd make a couple jokes about that, but I don't think it's a wise idea, all right? But you can probably imagine the jokes I might be thinking, all right? Memorandum of understanding. It's basically an agreement between two parties where it outlines who's responsible for what. And, these are more or less legally binding, depending on how they're written. All right, if both parties agree to it and sign it, then it should be somewhat legally binding. Okay, so addressing personnel safety. All right, so there's a lot of things that go into this. Anytime you have a business that's open to the public, okay, are there crazy people? Yeah. So is it fair to say that at some point a crazy person is going to go into a business open to the public? Yeah. So you have to figure out how you're going to protect your employees and also protect your company. Okay, because let's face it, there's nothing more important than profitability. All right? And if your company's getting robbed every day, that's not going to be very profitable, is it? All right? And, beyond that, if your employees are at risk, you're not going to have employees, are you? All right? So this is important. All right? First thing, a duress system. Okay, so duress system is basically going to be an alarm system. And it can be triggered in a lot of different ways. There's certainly lots of different possible trigger points, like you could have a little panic button. Sometimes you could have a certain code. If you insert it into the cash register, it'll trigger an alarm. Obviously you have like glass break sensors, fire sensors, those sort of things. But the idea is that in some cases it makes sense to do a silent alarm. In some cases it makes sense to do an audible alarm. Certainly with a silent alarm, it's possible you may be less likely to face danger. It's It's also possible that an audible alarm, you may be less likely to face danger. I really don't know. I think that it's going to be heavily situation dependent. All right, because let's face it, if you're in a very busy downtown area, you know, is an audible alarm going to alert people? Probably will. Say you're in a country location, you got an acre to yourself. Then an audible alarm's not going to do much, is it? And beyond that, you know, it's kind of a morbid topic, isn't it? All right. Let's talk about something happier. All right, traveling. Who likes to travel? Ron, where's your favorite place to travel? Florida, okay. Going down to PCB? Okay. Not too familiar with there. Sydney, where's your favorite place to travel? Okay, what part? Okay. It's a nice area down there, certainly. All right, so imagine you're traveling to a country of your choice that we're not too friendly with. All right? Think about China. Think about Russia. We don't have the best relations with them, do we? Okay? So if your company's traveling there, you know, how do you ensure that they're protecting the data that they have? Okay, well, there's a lot of different ways. Probably the most important way we talked about for several chapters in here. All right, it's going to start with an E. Who can tell me what it is? Encryption. All right, because if you encrypt data, does it matter, assuming it's with a reasonably secure encryption algorithm, does it matter if they get it? Not really. I mean, it does kind of depend, but if it's encrypted with 256-bit or 512 or even higher than that, they're not going to be able to crack that in a very short time, are they? Okay, so sensitive data. You want to make sure that you're keeping that secure, all right, through encryption, through maybe even the ability to remotely wipe a system. All right, because if you remotely wipe encrypted data, it's almost impossible to recover. All right. Well, I wouldn't say remotely wipe. I would just say if you wipe it, remotely or not remotely. Okay, so that's an important concept. Beyond that, you want to make sure that you're having malware and monitoring services on the device that you're going to be taking overseas. Well, let me rephrase that. Anti-malware system. Definitely don't want a malware system on there, do you? That'd be no good. Okay? So, the idea is that you want to ensure that no one's installing anything malicious. All right, that's pretty self-explanatory. We've talked about anti-malware systems a good bit in here. I'll even add to this. You'd probably want to limit the drive access and limit the privileges of any overseas user, particularly in less friendly to the United States nations, if you're a United States-based company. All right, let's say you're a Chinese company. You got someone coming over to the U.S. Same would apply. Stuff doesn't exist in a vacuum. Okay, it's real stuff. Network access. It's an important one. You're overseas using someone else's network. Do you trust it? Okay, who would trust an overseas network? Who does not trust an overseas network? Ron, why don't you trust it? Okay, it is possible, certainly. So how can we prevent that? What's one mitigating approach? A VPN. Okay, that will certainly prevent them from getting access to the data on the system. Now beyond that, say we want to restrict file access. What can we do? Straight up disable it for non-company networks, right? Definitely. Okay, so traveling is risky. I'm not going to sugarcoat it and say it's all fun and games. It can be fun, but it can also carry some risks. Okay, so your company has to mitigate those risks. And again, we've talked about that throughout the semester. Okay. Another thing to keep in mind, you want to have emergency management procedures. Okay, so a big component of that is going to be formal processes that document what to do in certain situations. Which again, you're basically doing that for this project in here. Okay, so you're working with your group to come up with a formalized set of procedures. All right. So it's not just though about the procedures and the processes. Okay, it stands a lot beyond that. Okay, so whenever you are going through and you're creating these policies, it's also about the training. Okay, because you can have all the policies in the world, and if no one knows they exist, what good do they do? Do they do any good? Minimal, if any. All right, so it's about disseminating that information, training. Okay, and then another component of training, security education, training awareness. All right, now I personally would recommend that you pick a good program. All right, I'm not going to comment on those anime videos. All right, but you can make of that what you will. If you think that's a good program, I'm not going to ask, but I'm sure that there's a varied opinion on that. All right, so make of that what you will. Provision resources securely. All right, this kind of goes in to talk about information and asset ownership, which we really talked about the different roles in Chapter 5. Okay, so you got the asset owner. Okay, then you have the data owner. And then you have the data, well, there's a lot of roles. Okay, so it's really about just making sure that you're following those and that you're having the best practices in place to ensure that you're having secure data. All right, asset management. There's a lot of different types of assets. Okay, so one that's not even up here is property and plant. And I guess equipment's kind of up here with hardware, but by and large, it's probably going to be your biggest classification for a lot of companies. So how do we secure property? Okay, locks for the, but what are we going to lock up for a piece of property? Talking like 20 acres. You're going to lock up a gate. What's the gate attached to? A fence. All right, let's face it. If you have an 8-foot fence with razor wire, it's not going to be easy to clear that. I'm not saying it'll be impossible, but is it fair to say it'll be a deterrent to a whole lot of stuff? I think it will. Okay. Now again, there's a lot of ways to clear an 8-foot fence, especially with razor wire. That's not impossible, but it's going to be noticeable. Pretty much any way you clear it, it's going to be pretty noticeable. Let's say you get a thick jacket or a thick blanket, you put it over the razor wire and you climb it. That could be spotted pretty easily, right? Say you get a 10-foot ladder, plop the ladder in between. That could be noticed pretty easily too, right? Let's say you cut through it. You're making an electric gate fence. It's possible. You want to check the local laws and stuff. I'm not a lawyer. But let's face it. You'd have to be pretty stupid to cut through an electric gate, wouldn't you? Why? You get zapped. All right? Gate. What else can we do to secure a piece of property? Okay, lighting. Something's well lit. A lot of more rationally minded criminals wouldn't want to go because they might be more likely to be detected. What else? Okay, cameras. All right, if you have cameras that are visible, people may not want to be recorded committing a crime if they're thinking rationally. What's the problem with criminals? A lot of them don't think rationally, okay? And this isn't a criminology class or anything. You can probably imagine some possible reasons why a criminal may not think rationally. All right? I'm not going to go into it, but it's common sense. All right? What's a couple other things we can do to protect a piece of property? I don't mean anything silly like landmines or moats, but something practical. Security guard, exactly. All right, so if you have a security guard patrolling, they're going to be able to notice stuff and handle it. I'll leave it up to you as to what handling it may mean. All right. That's property. What about plant? What about our buildings? How do we secure a building? Lock the doors. What else? Okay, man trap. So a man trap, of course, being where you have basically multiple doors to enter something. Okay, so let's say this is our building. We have a door to get in and another door to get in. All right, and the idea is that you're putting in your credentials twice. And the reason that's more secure, if you just did it once, then someone could just kind of tailgate you. But with it being twice, it's a lot less likely to occur. All right, what else? Okay, an alarm system, certainly. You know, we can tell if someone enters. We can respond. All right. What else can we do to secure a building? What's that? Cameras. Yeah. Again, if you have visible cameras, rational people don't want to be recorded committing a crime. All right, because if they're recorded, it means you're going to get caught. They get caught. What happens? They go to jail. All right. Criminals belong in jail. That's another ethical thing I'll say today. How about that? Hardware. So we talked about some different ways to secure hardware. You know, a lot of it's going to come back to having strong policies in place to keep it secure. Don't leave it sitting out. Lock up the stuff that you don't have someone at, basically. Beyond that, take inventory on it. You know, and you would periodically check the inventory to ensure that nothing has walked away. And by walked away, I don't mean that it literally walked away. I mean someone took it, used it without asking, that sort of stuff. Software assets. Why do we take inventory of them? You can't really steal software. Is it possible to steal software? Not really. Why can't we steal software? So it's not a physical thing. So can you make an unauthorized copy of software? Yeah. You can infringe copyright, definitely. But you can't steal it. Okay, because you steal something, it means you don't have it anymore. You know? It's like if I had a copy of an exam, okay, and someone walked into my office, I left my computer unlocked and my office unlocked. Let's just say hypothetically. Well, let's not use me as an example, actually. Let's say someone in a different school did that. I still have the exam, all right? But they took intellectual property from me. Or not from me, from whoever they took it from. Still wrong, but it's not stealing. It's not theft. It's unauthorized access, if anything, or copyright infringement. So why do we take an asset of our, or why do we take an inventory of our software? List off a couple of reasons. If you had a company, why would you want to know what software you have? Licensing, that's a huge one. Okay, because let's face it, you know, a lot of these large software providers like Microsoft, I know for a fact, they have a whistleblower system where, let's say that your company is using software in a manner inconsistent with the license. Microsoft, you could report it to them, and then you could get 10% of what they collected for it. You know, let's face it. I think that would be pretty enticing to a lot of companies, or a lot of employees, rather. All right? If you had the opportunity for a, six-figure payday, would you take it? Throw your company under the bus? Maybe, maybe not. But I think that out of 1,000 employees, I think it's pretty fair to say that someone would they not? That's why keeping track of software assets are important. It's not because they can be stolen. What do you care if a piece of software gets copied without authorization? Who cares? Does anyone care? But you care when it opens your company up to million-dollar lawsuits. All right, intangible inventories. It's intellectual property. All right, this is going to be a lot more important for some industries than others. Okay, if you have an industry that's pretty reliant on R&D, this is going to be pretty vital. You want to make sure that it's stored in a secure fashion. All right, you definitely don't want to just leave it out on a desk. If you have some new R&D, why not? Exactly. So if someone were to copy your R&D, okay, they ship it overseas or whatever, then do you have a competitive advantage from that? No, the whole point of R&D is to get a competitive advantage, something your competitors cannot reasonably, sort of match. So whenever we're thinking about it in those contexts, you want to ensure it's secure. All right? And anything that you do is going to be heavily dependent on what you're trying to secure. We just talked about some different examples. But in general, if you're talking about an information system of some sort, okay, some sort of technology, almost anything you're talking about is going to involve backup and redundancy. Okay, so can you recover from pretty much anything technological if you have a good backup? Yeah, ransomware. Can you recover from it with a backup? Easily. Well, I won't say easily, but easier than without it, certainly. Flood. Can you recover from it from an offsite backup? Yes, you can. All right. There's very little in technology that you can't recover from strong backup policies. What makes a backup policy strong and robust? Okay, so frequency is a big part of it. What else? You definitely want to have off-site backups and probably off-locate. So if you're a Durango-based company, you don't just want to have your backup in Durango, do you? You don't want to disperse it. All right, so that's another good component. What else? Frequency, location. What else makes a backup policy robust? Okay, so you want to make sure that it's covering everything, right? Those are all important components of backups. Shifting over to redundancy. How can redundancy help us recover from a disaster? Exactly. All right, so any type of disaster you can imagine. All right, let's say you got a power outage. You have a redundant system in another location. Can you not switch over to it? You can. Let's say you have a power outage and you only have a single location. With redundant power sources, can you not switch to a diesel generator? Can you switch maybe to some sort of solar? Probably a lot more difficult and costly than a diesel generator. But it is possible, okay? So, redundant ISPs. What if one ISP has an issue? Switch over to the other. That can happen in a matter smaller than milliseconds. Is that pretty cool? I think that's pretty cool. So, does everyone understand how backups and redundancy can help us recover from pretty much any technology problem? Does anyone disagree with that? It's okay if you do. I'm always up for a good debate. All right. Media management. A lot of different types of media. Okay. Certainly pretty much any of them are going to need to have a reasonable temperature. All right, so some are going to be more sensitive than others. A solid state drive is going to be a little bit more sensitive than a magnetic hard drive when it comes to temperature. Good news is that neither of them are going to be particularly sensitive to reasonable temperatures. Both can withstand 100 degrees Celsius. All right, is 100 degrees pretty hot? It's boiling. All right, you shouldn't be in an environment that's 100 degrees Celsius. In fact, you wouldn't be able to survive for more than a couple seconds, I believe. Now, look, I'm not a biologist, but I don't think that the human could really survive in boiling, conditions, 100 Celsius. Feel free to disagree, but I don't recommend you actually try to prove me wrong on that. I shouldn't have made that joke, should I? Anyway. Then you got stuff like tape drives. Tape drives are highly sensitive to heat, humidity, dust, anything you can imagine. But they're cheap per gigabyte. They're very suitable for long storage, assuming you have reasonable climate controls. All right, they can last 30 years. I guarantee you, a mechanical drive is not going to last for 30 years, is it? Probably not. So certainly keep in mind the media that you're using. Even stuff like maintaining a reasonable mean time to failure. Okay? So the mean time to failure is basically saying, when is the drive likely to begin to fail? And for stuff like solid state media, this is even more important than with mechanical drives. Because let's face it, what happens when a solid state drive fails? Anyone ever had an SD card fail? Solid state drive, what happened? Data's just gone, isn't it? Now with a mechanical hard drive, in a lot of cases, you may have a couple bad sectors here and there, but you can probably still recover the data from it when it's failing, right? Probably. Not going to say you can 100%. But for the most part, you get a lot more warning with mechanical hard drives than you do with solid state drives. Okay? So, with modern solid state technology, using stuff like NAND, it's going to have a whole lot of read-write cycles. But there's not a drive that has unlimited read-write cycles, is there? Will there ever be? I think it's unlikely, at least with the current technology. I'm not going to say there will never be, but I think that it'd be difficult to manufacture. Because let's face it, is there anything that lasts forever? Okay. Even a stone engraved tablet is going to fade over time, isn't it? So I don't know that we'll ever get to that point. It's hard to say. I mean, we've come such a long way just in the past 10 to 20 years. So I'm not going to say we won't. I'm just saying I'd be surprised if we do. Having said that, I think storage will get a lot faster. I think it'll get a lot less expensive. I think that trend will continue for quite some time, but I don't think it's going to last forever no matter what. I could be wrong, though. Who thinks we will get a drive lasting forever? Why do you say so, Ron? It's possible. I'm not saying it's not possible. I just think that with the current technology and sort of what's on the horizon, I don't personally see it happening. I think we'll probably move away from a lot of physical conductors. I think that'll probably improve reliability. I think we're probably going to move more toward optical for a lot of things. Not everything, of course, but I think that optical will be, and I don't mean optical as in like a CD. I'm talking optical like fiber transmitting via light instead of via conductor. I don't know. We'll see. Media protection techniques. We talked about that. Tape media. We talked about that as well. Mobile devices. All right. How do you protect a mobile device? Who has a mobile device in here? Colton, how do you protect your mobile device? Okay, well, I'm not talking about physically, though. Okay, so what you're saying is that use a password to access the mobile device. Okay, and that's certainly one way to use full disk encryption on it. Okay, well, that'd be another way you could. Who uses Android in here? Ron, do you full disk encrypt? You know you could, though, right? Well, you can. Um, so, yeah, it kind of depends on what you're using. Now, from an enterprise perspective, talked about this a little bit. Let's play Hangman. 3 letters, what an enterprise would use to push policies and other stuff to a mobile device. Guess a letter. Mobile device manager. Exactly right. Thanks for saving our guy. I appreciate it. Be a sad day, wouldn't it? All right. So mobile device manager is going to allow us to push basically whatever policies we want. Okay, we can allow or disallow apps. We can use a whitelist for apps. We can use a blacklist for apps. Certainly we could only allow company email to be on a device owned by a company. We can even push various controls like what websites we're allowed to browse on non-company networks. Obviously, with company networks, you'd have that ability to do so anyway. All right. A lot of things we can do with an MDM. All right. It's also a great way to just keep track of the device itself. So let's face it. You assign a device, you might not see it for 2 or 3 years. Is that fair to say? It allows you to keep track of which devices you're actually using that are company owned. All right. Any questions? Yeah. So that's a great question. Are you talking about Mac or are you talking about iOS? So there's a lot of MDMs that would support both platforms, and there's some that are just iOS devices. But yeah, it'd still be an MDM. Now, if you're going to ask about Mac, you'd probably use something like JAMF or JAMP. How's it pronounced? I've heard it both ways. But either way, it would allow you to basically do similar stuff to group policy on Windows. Does that answer your question? So yeah, I mean, pretty much anything you're doing with a mobile device, you're going to find a mobile device manager that supports the platform or platforms your company is using. It's obviously possible to use multiple MDMs, but that's going to be pretty cumbersome to manage. So why not just do everything with one? Manage services in the cloud. Okay? So, yeah, the number one thing you're going to do putting something in the cloud is encrypt it. All right? And we're going to encrypt it at all levels. Okay, we're going to encrypt it at rest, we're going to encrypt it in motion, and we're going to encrypt it in use. All right? Now, it's particularly sensitive. You probably don't just want to plop it on any old cloud. All right, particularly in the age of CPU vulnerabilities. So let's face it. If you're using most CPUs, all right, are there known vulnerabilities in them? Yeah. Okay, are there unknown vulnerabilities? Almost certainly. All right, I'm not going to get into any of that, but just understand that, for especially a complex instruction set, so not necessarily like a reduced instruction set, but for a complex instruction set processor, anything x86, anything x64, well, not anything x64, forget I said that, but certainly anything on the x86 architecture, all right, it's going to have vulnerabilities and exploits. That's a fact. It's not an opinion. You can pull them up and look at them for yourself, okay? So the reason you want to consider a private cloud is if you're on a public cloud, there may be 10 or 20 other people using your particular piece of hardware. Okay, if you got 10 or 20 other people, one of them may purposefully or accidentally install something that can exploit one of those vulnerabilities and access what's on your VM. That'd be very bad, wouldn't it? Okay, that's why the government, for sensitive stuff, that's why they have private cloud agreements with Amazon and Microsoft. A couple years ago, there's a big bid that went out. I think it was for the Department of Justice. And they had a $10 billion bid, and it was between 4 companies. Microsoft, Amazon, Oracle, and I think the other was IBM, but I'm not sure. Oracle and IBM didn't make the cut. But it was between Microsoft and Amazon. Amazon lost, and guess what they did? They didn't bend over and take it. What'd they do? They sued. Exactly. All right. So look into that case if you're interested. It's an interesting case, though, because the government wanted a private cloud. Let's face it. Do you think the Department of Justice understands the CPU vulnerabilities? Almost certainly. All right. So they're not going to be putting sensitive data on a system that's, in a way, a shared system. Now, not to say that those vulnerabilities are actively exploited, especially on desktop systems. When you start talking about servers, that's a big concern. So the idea is that there has to be some level of shared responsibility. So you have your company contracting with a cloud vendor. Some of it's the cloud vendor's responsibility, some of it's yours. Talk about the different types of cloud vendors. Okay, you have software as a service. It's where an application is hosted by the vendor to your company. As you can see, everything from the networking layer up to the application layer, all of that in between, it's going to be managed by the vendor. Because basically, you don't have any control over how they're doing the networking, do you? If you're using Office 365 online, you don't get to tell Microsoft how they run the network. You don't get to tell them where the data goes. You don't get to tell them what application. It is what they host. Platform as a service. Okay, so this is where you're basically being hosted a functional operating system. And you can install whatever you want on the operating system. But you don't control the operating system. That's controlled by the vendor. Only what's installed on the operating system. So your data and applications. All right. Then you have infrastructure as a service. So infrastructure as a service, as the name would imply, you're able to have the infrastructure, which would be a functional virtual machine with some agreed upon amount of resources. And then you can install whatever you want on that. So they basically give you a blank VM. And if you want to install Windows Server, you can. Install literally anything you want on it. They're not responsible for any of this. They're responsible for virtualization and below. All right, if you had localhost, that's not really a cloud technology, but who'd be responsible for what if it were locally hosted? Exactly. It'd be like the opposite of software as a service, wouldn't it? That's exactly right, Ron. So you would have application responsible by the company. That networking, the storage, servers, virtualization, operating system, data, applications, every bit of that would be responsible by the company. All right, so 2 major components, and these are vital. All right, you have scalability. So scalability is a term that is basically saying, is it possible to add resources? And that's an important thing. Okay, but probably more important than that is elasticity. Elasticity is the ability to dynamically add or remove resources. So elasticity for cloud supporter, or for cloud providers in particular, that's going to save your company a lot of money. Because let's face it, okay, we have 100% utilization and 0% utilization. Let's say this is for 24-hour window. Are we going to be 100% all the time? Probably not. It's fair to say it may look more like this. So why would you pay for this when you can pay for this? There's going to be a lot of cost savings with elasticity. And how does that work for a cloud provider? They still have to have 100%, right? Is everyone located in the same time zone? No. So you got companies in Europe. You got companies in Asia. You got companies in America. Okay? All using resources at slightly different times. So it works well for both the cloud provider because they're not having to have a bunch of overhead. Works well for you because you're not having to pay for their overhead. That makes sense. Now, in the real world, does anyone make that distinction? This is one of those terms that it's know it for certainly going out and taking the cert, but you don't want to be that guy who goes and sits there and argues about a definition. Why not? Who likes someone who argues with someone about a definition of a word all day? Exactly right. Okay? You don't want to be annoying. Don't argue about the definition. Configuration management. Three major terms to note here. Okay, you have provisioning. Okay, so provisioning is where you're basically implementing a new system. Okay, so you're doing the entire installation process, and that's referred to as provisioning. And generally speaking, the key word here is going to be new. So it's not something you've done before, basically. Then you have baseline. And baseline is going to be pre-established criteria for what the system should be. So it's something you've done before. Think about traditional, it's like a run-of-the-mill employee desktop configuration. So that's something you're going to have that you've done before as a company? Probably. Okay, so there's two ways to approach baseline. You can either make an image, or you can use procedures. All right? And basically, the way making an image would work is you have a baseline system, or you have a desktop engineer who's going to install everything needed and perform any configuration needed on the baseline system. Then that's going to be copied by an image server. The image server is going to allow you to deploy it to other devices. All right, really straightforward process. Lastly, you got automation. So name automation would imply it's doing stuff automatically. A lot of the time that's going to be stuff like group policies. Okay, so group policy, of course, would allow us to do whatever configuration we want to a Windows device. Very powerful tool. However, there's some drawbacks. Probably the biggest drawback is you have to be on the corporate network to use it, right? That's going to be a pretty big drawback. Let's talk about managing change. Okay, so most important thing about any change is to get buy-in. What's buy-in? Okay, you have to get support. Support from hopefully top level, but also everyday employees too. So there's 4 phases. Okay, you have the forming phase. All right, forming phase, you're getting together, talking about the change. Then you storm. All right, you argue about the change. Okay. Then you norm. You establish the change. Okay. Then you perform. All right. In the performing phase, you're actually going to implement the change. Okay. Pretty straightforward process there. So in change management, it's a little bit more formalized. Okay. This is going to be something that's going to be used primarily for the purpose of not deploying a change that breaks things. Let's face it. Who's ever run an update and broken something? No shaming. I've done it several times. Okay. Well, this is why you don't do that on a company scale. All right, so first request the change. All right. Then you have a team who's going to review the change. It's usually going to be comprised of managers from different departments in IT. So you might have the sysadmin, you might have like a network admin manager, and then just all those sort of positions. They're going to decide whether they accept or reject it. All right. Most of the time, they're probably going to accept the change. Is that fair to say? Most of the time. Unless it's a bad change. Then you're going to test it. Now, this is a vital step. You don't test it in production. You have a dedicated test environment, and it's going to be as realistic as possible. And you're going to test it in there. And if it doesn't break anything, then you schedule and implement the change. Finally, you conclude by documenting the change. All right. Change management process makes sense. All right. Patch management. Looks like I got a little typo here. All right. So the first thing you want to do in patch management, you want to document what systems you have and what software they're running. Is it not impossible to patch systems without knowing what you have? It's impossible. So you want to keep track of updates for said systems. Okay? And specifically, you'd want to keep an eye on things like, the CVE. Okay? You want to keep an eye on that entire system. All right? You're going to evaluate your patches. See what they do. You're going to test them. Okay? And if they go fine, you're going to approve, deploy, and verify. This is an important process as well. If you don't deploy patches, you're going to have vulnerabilities. You don't want vulnerabilities. All right, so vulnerabilities. So, even though you patch regularly, you still want to scan for vulnerabilities. Now, we talked about several tools in here. We're going to be doing some of that the next couple labs. Okay? But the idea is we're just following the best practices. All right, so we're not going too crazy with this. We're just regularly scanning all of our systems for vulnerabilities. We're still in class. Okay? So you're just doing that. All right? So just to wrap up, we talked about applying foundational security concepts, addressing personnel safety. Talked about provision resources securely, applying resource protection, managed services in the cloud, performing configuration management, and managing changes. Any questions? All right, that's all I got today. Have a good weekend. We will not have class Monday. It's going to be a day to work on the project. So if you got me for 2 classes, work on whatever you want for whichever project.